My name is Alex Zambelli. I'm a technical evangelist for the Microsoft Media Platform. And probably the first question on your mind today might be, what is the Microsoft Media Platform? It's a term that we haven't really been using necessarily for a long time. You know, we've been developing a lot of media technologies in Microsoft over the past several years, and some of them independently, and then some of them, to work together. And so, we've always been using them to build media solutions, and so we come to think of them really as a media platform. And we decided, we should really put together sort of an umbrella brand for these set of technologies. So that's really what Microsoft Media Platform is. It's an umbrella brand for a set of Microsoft technologies that you use to encode, deliver, protect, playback video, really to build internet media streaming solutions. And so the Microsoft Media Platform really encompasses a number of other Microsoft technologies that you might know by other names. This is a good overview, for example, of what goes into the Microsoft Media Platform. Probably starting from the what I would consider, I guess, the first step in the path of delivering and building a media solution will be the services. Basically, how do we deliver the media? And so today we have two primary components that we use to deliver media. Two Microsoft components that we use to deliver media. That would be Windows Server and using IIS Media Services. That's our on-premise technology for building media servers. And then we have Windows Azure, which is becoming more and more important as we transition to the cloud. We have a set of tools for encoding media. So we have Microsoft Expression Encoder, for example, which is our in-house encoder tool. And then we also have PlayReady DRM, which we use to encrypt and protect content. Then we have a set of client technologies that we use typically to play back this media on once we deliver it. We've been using Silverlight a lot for the past few years. As HTML5 is emerging, we're obviously embracing that and adding that to our set of client technologies as well. And then, especially in the context of smooth streaming, which I'm going to just touch a little bit upon later, we've also developed a number of porting kits, the Smooth Streaming Porting Kit and PlayReady Porting Kit, to really enable delivery of adaptive streaming media, protected adaptive streaming media, to platforms such as iOS and Android and other platforms such as set-top boxes, for example. And then finally, the last piece of the Microsoft Media Platform is our frameworks. We realized that having products out there is not enough, because a lot of times if you put just an encoder product out there and a server product out there, there's not necessarily things to connect them together to really solidify that workflow. And so what we've been doing over the years is building a number of frameworks that make the process of building media streaming solutions a lot easier. So one of them, for example, is our Microsoft Media Platform Video Editor, which we use to essentially do rough cut edits of smooth streams that are already in the cloud, so you don't have to go and actually re-encode highlights. You can just reference them in a playlist and then play that directly from the cloud. We have a content manager solution, which is a very basic CMS framework. We have a player framework that we basically use for building rich media players. Rather than having you start from scratch, you can just start from the framework and start from a much more functional level. And then finally, there's the Audience Insight framework, which we use to essentially analyze and interpret media usage data. And so that's what we consider today the components of the Microsoft Media Platform. Now, this session today is about HTML5 and how HTML5 fits into the Microsoft Media Platform. And so before we consider which components of this that you see on the screen go into our HTML5 world, we have to think about HTML5 and certain constraints that come along with HTML5. If you had a chance to read the HTML5 video specification, and I encourage you to do so, obviously if you're here you have an interest in HTML5, and it's really useful to actually read the spec and know what's in it and what's not, and kind of read through a lot of the reports and blogs and so on that have been talking about HTML5 for the past several years. The HTML5 video specification really addresses only a basic set of video delivery scenarios. Some might refer to this as the YouTube scenario or the user-generated content scenario, because we're typically talking about what's HTML5 video good for. It's really good for the type of scenarios where you have basically just progressive download of a media file that doesn't require DRM protection, doesn't require adaptive streaming, doesn't require live streaming. And that's because if you read the HTML5 video spec, you notice that there are some key features actually missing from the specifications, such as there's no actual traditional video streaming that's addressed in the spec. So there's no RTSP or proprietary technologies such as RTMP or anything like that referenced in the spec. There's no reference of HTTP adaptive streaming in the specification. And there's also no mention of content protection, so there's no form of digital rights management in there. A lot of people have been using, for example, Apple HLS to deliver to HTML5 on iOS devices such as the iPads and the iPhone. And so a lot of people tend to think, when we say, oh, there's no HTTP adaptive streaming in HTML5, they go, well, what about HLS? I've been using that to deliver to iPads. And the thing there is that Apple HLS is actually not a part of the HTML5 spec. It's just a proprietary standard, just a proprietary extension of Apple's implementation of the Safari browser. So that's actually not part of the specification. So for all intents and purposes, really the scenarios that we're looking at for HTML5 is really progressive download of unprotected clear video on demand. So if that's the scenario that's interesting to you, then HTML5 is a suitable answer for you. If you want to do more, if you want to do live streaming, if you want to do protected content, then you probably want to be looking at some of the other technologies, client technologies such as Flash or Silverlight or others. So coming back to the Microsoft Media Platform, now that we know what the constraints of HTML5 are, let's kind of take a look at what components of the Microsoft Media Platform actually are applicable to the HTML5 context. So first one will be Windows Server and IIS Media Services. IIS is the web server of Windows Server, and that's what we would use, obviously, to deliver progressively downloaded media to an HTML5 browser. We need to encode that media somehow, so Microsoft Expression Encoder is still applicable here. Of course, obviously, we're going to be talking about HTML5 today on the client side, and we're going to be talking specifically about Internet Explorer as Microsoft's implementation of the HTML5 browser. And then finally, of the frameworks, the most interesting one to us is going to be the Player framework, because we've done some work there to add HTML5 capability to our Player framework as well. So let's talk about the Internet Explorer first. The latest version of Internet Explorer is Internet Explorer 9, and that's been around since March of this year. In IE9, we added support for HTML5 video and audio tags. And that means we have native H.264, AAC, MP4 file support in there. If you are interested in WebM playback, Google's WebM standard, I shouldn't say standard, Google's WebM implementation, there's actually a plugin for Internet Explorer that you can download that enables playback of WebM in Internet Explorer 2. But today we're going to be focused on H.264 because that's what we natively support in Internet Explorer. One of the big advantages of H.264 and why we prefer the Internet Explorer is because we actually have full hardware acceleration of H.264 decode work in Internet Explorer. That means that when you play back any H.264 video in Internet Explorer in HTML5, you actually, it's not the CPU doing the decode. Really, the entirety of the video decode is actually being done by the GPU, by the video card. Why is that important? It's really important because it reduces power consumption, and that in turn reduces, extends battery life on mobile devices and laptops and so on. And so today we're increasingly using more and more netbooks and slates and such devices of that form factor, and it's really important that they can handle HD video, which is becoming the norm for delivery of video over the internet. If we were just up to playing video on the desktop, we really probably wouldn't be talking about hardware acceleration as being such a big deal, because today most desktops have dual core, quad core, even more cores than 4, and so they can actually really easily handle HD video, even 1080p video in full resolution, just decoding it on the CPU. But when we talk about the devices such as netbooks, they're typically low power devices that typically use Intel Atom processors. There may be single core, maybe dual core, not much more than that. And so it's very important that not only that they can handle the playback, smooth playback of HD video, but that they also don't, wipe out the entire battery in, trying to play back a 2-hour movie. And so what are the specs, basically what are the acceptable specs of media that you can play back in HTML5 and IE9? So the file format that we support is the MP4 file format, also known as the MPEG-4 Part 14 specification. The video codec is H.264, also known as MPEG-4 AVC. And we support baseline, main, and high profiles of H.264. Of those, actually only main and high are hardware accelerated. Baseline is not, because it's low complexity enough that doesn't actually need to be accelerated. We support up to level 5.1 of H.264. On the audio side, we support the advanced audio codec, AAC. And we support all major flavors of AAC, which is AAC-LC and HEAC, both version 1 and version 2, up to 48 kilohertz. And then as far as transfer of the media, we support, of course, HTTP, aka progressive download. And we support both HTTP 1.0 and 1.1 specifications. You really want to be using HTTP 1.1 because that gives you the advantage of doing instantaneous seeks. Basically, that allows by range requests, and that allows you to seek anywhere in the media, even though you haven't downloaded the whole media to your computer. So I'm going to do a quick demo of basically what GPU-accelerated H.264 playback looks like in IE9. So what I'm actually going to do first, I'm going to go ahead and I'm going to disable GPU acceleration in IE9. And in order to do that, if you go into Tools, you can actually switch to the software rendering mode of IE9. And so I'm going to go ahead, I'm going to play back a video that's actually a 1080p full resolution video. Encoded with really difficult complexity. It's got, if you're familiar with H.264, it's encoded with Kback and 7 B frames and I think 7 reference frames. And so it's a pretty hardcore clip as far as complexity goes. And I'm going to play it back, and it might play back okay. Like you might see draw frames, you might not see draw frames. But the important part is that if you look at the, oh, I'm sorry, actually, let me restart this. I forget that when I change the rendering mode, I need to restart the browser. There we go, okay. So we're going to play back that. There we go. So it's a little choppy, as you can see. It's dropping frames, and if we look at the CPU consumption, we can actually see that it's using 90 to 100% of the CPU. So it's really taxing my CPU right now. It's pretty much creating a bottleneck in the decode, and that's why it's dropping a whole lot of frames. You can see the video in the background is pretty choppy. There's a cool utility out there called GPU-Z. It's a freeware utility. If you look for it online, you'll find it pretty quickly. It's a free download. This will actually tell you how much of your GPU is being used. It's sort of the equivalent of looking at CPU usage. And right now you can see that we're not using very much of the GPU. We're only using, let me zoom that in. See that number right there? That's basically, we're only using about 10 to 15% of the GPU. So I'm going to minimize that, and I'm going to close, oops, let me reopen that again. And I'm going to go ahead and I'm going to now disable software rendering and put it back on the default hardware accelerated rendering and decode. And I'm going to restart the browser. I'm going to go back and play that video again. Now remember, that's a 1080p video, full resolution. I think it's about 25 megabits per second. I'm playing this locally, so it's actually being able to download it from my local machine. But it's definitely a very challenging video to play. And you can see now it's playing much smoother. I don't think it's dropping any frames at all. And if we go look at CPU consumption now, you can see that it's actually dropped to 35, 20%. I mean, it's basically, it's gone down to about 1/3, 1/4 of what it used to be before. And it's not creating a bottleneck anymore either, so we're actually able to smoothly play it back without dropping frames. And then if we look at the, oh, there it is. If we look at the GPU consumption, you can see that we're actually using about 60 to 70% of the GPU right now. And that's because GPUs handle the decode. So that's more power efficient, and therefore that's actually using less battery on my machine. All right. So what does it take to actually build an HTML5 player? It's actually surprisingly easy, which is the point exactly of HTML5 video, and that's why a lot of people are excited about it. This is all this code you see on the screen, and I'll zoom in a little bit if you can't see it. That's all it takes to build an HTML5 video player. A very basic player, of course, but that's all it takes. I'm sure you'll see thousands, not thousands, but I'm sure you see dozens of demos like this at the conference, because I'm sure everyone's going to be showing some HTML5 code, so get used to it. But this is basically all it takes. You basically just need to define a video element and define its width and height, and then define a source for it, point it to a MP4 file on the server, insert some little goo over here that defines the MIME type, which is video/MP4, define the codecs. That's basically prefixed. You're always going to be using this for H.264 and AAC, and that's all it is. And that's your video player. Of course, the devil's in the details. There's a lot more to it. Obviously, we wouldn't be having all these sessions about HTML5. There's a lot more complexity to it once you start getting into things like, doing the fun stuff with the video, like forming video walls and rotating it around and making it fly, and applying transforms to it and whatnot. And of course, if you want to do things like rollover, automatically detect whether a client has Flash or Silverlight or HTML5, and then pick the right appropriate player, there's more complexity in that. So, in order to alleviate some of that complexity, we have a player framework that we, in the past, we started out by building a player framework for Silverlight. That was the first version of the Microsoft Media Platform player framework, and we did it because we actually did a number of projects where we would go and we would pay an outside agency, an external vendor, to go build us a player for a project. And they go and they spend several months building a player, and then we use it for like a week, and then we throw it in the trash. And then we go to the next project and then hire another agency to do the same thing all over again. And after about 3 times, we realized that was really not the most efficient way of spending our money. And so we decided we should actually just have a player framework that we can use for providing all the rich functionality that we need in the player. And for Silverlight, that's a lot of things, because it's there's more functionality and more features in Silverlight than there is in HTML5 as far as video playback goes. So the Silverlight player framework contains things like adaptive streaming support and DRM support, and ad insertion and markers and captions and so on. We then went and extended that framework to the Windows Phone 7 platform as well, which is also Silverlight based, so it was a pretty easy port. And then the latest incarnation of the player framework is the HTML5 player framework. And that's currently in what we're calling preview 2, I think, or beta 2 is perhaps might be a better way to call it. That's going to be, we're going to release version 1 very soon. You can actually go and download already the betas from playerframework.coplex.com. What's in this HTML5 player framework? So one of the things we wanted to do is we wanted to make sure that if you're familiar with the Silverlight version of the player framework, that you can interface with the HTML5 player framework in a very similar way. And so we made sure that the JavaScript API is actually consistent with the Silverlight version, so that it's very easy to switch between an HTML5 player and a Silverlight player. A part of that was also making sure that you can implement a graceful rollover between the two players. So if you want to deliver adaptive streaming media, like smooth streaming, for example, to a browser, you need to deliver that to a Silverlight player. And so we allow you to go and detect whether a person has a Silverlight player installed, and if they do, then that's the player that's going to get used. But if you're delivering just, for example, MP4 files from a HTTP server, then the HTML5 player might get used because that's the primary player for that. And so that's the graceful rollover that we implemented. You can declare your player both statically as just markup. You can declare it, you can inject it into your project just via JavaScript code. The player currently supports playlists. It's a pretty pluggable architecture in there. The media and the controls is actually like the media sources, and the controls are separate modules. We provide, it's fully skinnable, so you can use CSS to customize the controls. And then finally, we implemented the full screen control, which ironically is not a given in HTML5 video. Another thing that they didn't really quite think through, I think, in the spec. But it is possible to do full screen playback in HTML5 video, and we do support that in the player framework. So a quick demo of what that looks like. So here's a video, and so as this plays back, you see that you basically have exactly what you would expect from your average video player. You have your controls down here. They can go away if they're not being used for a while. You have your seek bar. You can seek within the video. You have your play pause here, volume control, mute button, and of course, if you need to go to full screen, you can actually go to full screen. So if we go and just take a quick look at the source code for this.
Is that example adaptive that you're playing, or is that straight?
This is just MP4 video. So this is our HTML5 player. And let me see if I can. So this is the source code for that video player, and I'm going to zoom in so you can see a little bit better. It's pretty straightforward. I essentially just reference my player framework JS right here, and up here is my video instantiation. I point it to my MP4 file. I give it a size, and down below here, I initialize my player, and that gives it the skinnable UI and things like the control bar that you see. That's the JavaScript code that you see down here. So all this, if you're not familiar with JavaScript and HTML5, you could probably very quickly build this player on your own just by taking our JavaScript library, deploying on your web server, and essentially copy and pasting a little bit of code. So we plan to expand, of course, this player with many more features. We plan to add things like closed captioning, subtitling, more richer playlist support, and so on. So expect more features to be added to this player framework. This is just version 1 that we're releasing now. All right, so now that we talked about the client, let's now take a step back. We're kind of working our way, as you can see, from the client back towards the server. So the next thing we're going to talk about is expression encoder. Now, expression encoder is our video production tool for the web. I would call it a prosumer level encoding tool. It's not. It costs about $200 retail, and it's essentially used for simple editing, live encoding, DRM encryption. It supports also screen capture. And if you are building a Silverlight player, you can actually, it even provides player templates that let you deploy and publish a player immediately to the web. That's a Silverlight player. It supports closed captioning and many other features. It's a pretty flexible encoder in terms of the inputs that it supports. It's based on its input source model is based on direct show and QuickTime. So if you have the right directional filters installed and if you have QuickTime installed, you can essentially import anything that you can play back in Media Player or play back in QuickTime Player, and you can import any of that into Expression Encoder. As far as its outputs, it supports MP4 files, so that's H.264 AAC contained MP4 files. It supports WMV output Windows Media files, also known as ASF files, and that's with the VC1 and WMA codecs. And then it supports smooth streaming, and I'll talk about smooth streaming a little bit later in case you're not familiar with it. And that can use a variety of codecs that can use any of the above, so H.264, VC1, AAC, or WMA. There's actually a free download of Expression Encoder. You can go and try it out for free. The free version only includes VC1 and WMA support, so you can't actually author content for HTML5 using the free version of the encoder. You have to purchase the retail version, which, like I said, is about $200 retail. And if you got volume licensing, you can probably get it for much cheaper. So just in case you're curious, we use main concepts, H.264 and AAC codecs on the inside under the covers. We don't make our own. We actually just license main concepts. And a part of that codec package is actually support also for hardware accelerated encoding, which is a very cool feature. So we've supported this since Service Pack 1 for Expression Encoder 4 when we introduced support for NVIDIA CUDA. And then with Service Pack 2, which we just released last week, we also added support for Intel SQV. What this means is that much like you have the ability in Playback to offload all that work to the GPU and save your CPU some cycles, this allows you to leverage the GPU to accelerate the encoding of your video. And that's primarily beneficial to cut down encoding times. So unlike Playback, it's not about power consumption. This is about how do I accelerate the actual encoding of my video so I don't have to wait 3 hours for my 10-minute clip to finish. When you're encoding a video for IE9, obviously you have to consider certain things. Today, a vast majority of PCs that are running IE9, that are capable of running IE9, have GPUs that are capable of decoding H.264. And so if you actually want to deliver the best quality video to IE9 using Expression Encoder, I recommend that you encode using H.264 high profile to give you that best quality, because it's going to get offloaded to the GPU anyway. So you might as well just plan for the best quality rather than for the lowest common denominator in case the 3 PCs that can handle it can play it. The rule of thumb, in case you're wondering, okay, what can actually play back in IE9 as far as my H.264 video? The rule of thumb is that if you can play back in Windows Media Player and Windows 7, you can probably play back in the browser as well, because it uses essentially the same codecs and the same code path to do the decoding and the rendering as Media Player does. So that's a good rule of thumb. I'm not sure if it's 100% true, but it's a rule of thumb. So if you want to know more about what exactly the Windows 7 decoders support in terms of what exact flavors of H.264 and AAC, you can go and check out the Windows 7 codec documentation online on MSDN. And I provided a link for you in case you want to read up more on that. So I have some best practices some guidelines that I use when I encode video for HTML5 or Silverlight or Flash for that matter, in fact, because today Silverlight and Flash also provide hardware accelerated H.264 decoding. So you can't really lose. Essentially, if you use H.264, it's going to get accelerated regardless of whether you use HTML5, Flash, or Silverlight. So I recommend, like I said, that you use high-profile H.264. I recommend that you use Playback entropy encoding. That's a high-complexity encoding mode for H.264. And you can use three B frames. That's typically like a good target number, about 5 reference frames. And then if you have the option of using reference B frames or adaptive B frames, I recommend that as well. Typically when you encode for adaptive streaming, we don't recommend using scene change detection. But for HTML5, we recommend that you do, because you can actually get more efficient encoding if you use scene change detection. And because there's no multiple bit rates, there's no need to align actual GOPs and keyframes. So it's recommended that you use scene change detection for HTML5. And you can see a screenshot here of what those advanced settings look like in Expression Encoder. And in fact, for my next demo, I'm going to show you how to encode a piece of video in Expression Encoder. So this is Expression Encoder for Service Pack 2. I'm just going to show you very quickly how to do this. So we just click on the import button and we import a piece of media in here. I'm just going to import the short clip. And Expression Encoder, like I said, allows you to do some simple editing. So if you need to like trim the video, set some in and out points and things like that, you can do that using just Expression Encoder. But we're going to skip that and we're just going to go straight to encoding. There's a number of presets up here that you can use. And we haven't had the chance to update the UI and say, including HTML5. But if you basically target Silverlight with H.264 encoding, that will work in HTML5 as well. So if you want to just use a quick preset, just go to encoding for Silverlight, H.264, and you have your option whether you use constant bitrate or variable bitrate. Since we use in progressive download for HTML5, you might as well use variable bitrate because it gives you higher quality. You can use 2-pass VBR, and that will give you better quality overall. And with progressive download, progressive download tends to react to variable bitrate a lot better than, for example, streaming. So, for example, we might go and pick this HD 720p VBR preset. And then if we go and expand our video section down here, that will give us access to all the, there we go. That will give us access to all the advanced settings of the video. And so there's typical stuff in here such as bitrate and resolution. You notice up here there's a place to adjust the keyframe interval. For progressively downloaded video, unlike for adaptive streaming video, you don't need to have short chunks. There's no need to have like a keyframe every 2 seconds, for example, like there is with adaptively streamed video. For progressively downloaded video, you can insert keyframes every 5 seconds or every 10 seconds. If you're using scene change detection, the keyframes will probably get inserted more frequently than that anyway. So 10 seconds is actually like a pretty decent number. And then if you really want to tweak the settings for H.264, you can expand this section down here, and that gives you that advanced look, the advanced overview of the H.264 settings. So we can go in here and say things like, okay, I want to use 5 reference frames. I want to use 3 B frames. I want to use, actually I'll leave this in speed so it goes faster. We're going to use reference B frames and adaptive B frames and scene change detection. And for our audio, we're going to use 128-bit audio. All right, and once we're done, we can go over here in our output panel. Actually, I'm going to go ahead and disable the interlacing for this clip because it's a progressive video. And I'm going to set my output folder here. And that's it. And so we're going to go and hit encode. And this is my laptop, so I don't have a good GPU on this, so we can't take advantage of GPU accelerated encoding on this. So this is just using CPU. And you can see up here that this is going to take about 1.5 minutes basically to encode this, whatever it is, 20-second, 30-second clip. So I'm going to cancel that. We don't need to actually wait for the 1.5 minutes. I'm sure you have better things to do. But that's how simple it is to encode video for HTML5 using Expression Encoder. Let's see. Let me just check how we're doing on time. Okay. All right, so we talked about the client and we talked about the encoder. So you know how to play back the video and you know how to encode the video. So let's talk about how do you actually deliver the video and what can you get out of the Microsoft Media Platform on the delivery side. So Internet Information Services, aka IIS, is our web server for Windows Server. It's available in all the Windows Server 2008 SKUs, including like the cheapest one, which is actually called Windows Web Server. And the latest version right now is IIS 7.5 for the Server 2008 R2 release. Well, a lot of people don't know that IIS is actually available for Windows clients as well. So if you have a Windows 7 machine or a Windows Vista machine, you can actually install IIS on that machine. In fact, I'll show you right now where to do it in case you've never done it. It's kind of a hidden thing. If you go to Programs and Features, and you go to Turn Windows Features on and off, you can actually see that you can go and check this checkbox right there for Internet Information Services, and that will actually install Web Server on your Windows 7 machine. And that's useful if you're doing some development or if you're doing some demos and you don't need a full web server. This is kind of useful. And all the extensions that I'm going to talk about in a second, those work on the IIS version that installs on Windows 7 as well. So you actually, if you just, like I said, if you're doing demos, you don't even need a server OS. But obviously you do for important stuff. So IIS Media Services is a set of IIS 7 extensions that enhance delivery of media specifically over HTTP networks. So if you go to httpis.net/media, you can download IIS Media Services there for free, both for x86 and x64 versions of the server, of IIS that is. What IIS Media Services are is there's essentially a set of features, like I said, that enhance delivery of media. The most famous one that you probably have heard about is smooth streaming. That's our HTTP adaptive streaming technology that enables adaptive streaming of live and on-demand video. As I mentioned earlier, adaptive streaming is not a part of the HTML5 specification, so you can't, unfortunately, use smooth streaming to deliver to HTML5 clients. Somebody will probably ask, well, why not? Just extend the browser. Well, we could, but then we would essentially be going beyond the HTML5 specification. So in all likelihood, not. So right now, you can't use smooth streaming to deliver media to an HTML5 browser. Another feature that's a part of IIS Media Services is web playlists, and this is if you want to hide the location of your media assets on the server. It essentially allows you to obfuscate the URL so you can't see what the media is and where it is on the server, and this can be used for HTML5. And then finally, a feature of IIS Media Services is called Bitrate Throttling. And this is the one that I'm going to talk about in more detail because this is one that's most useful for HTML5 delivery of video. What bitrate throttling is, it's really a cost-saving bandwidth control feature. So you probably have all seen that scenario. You've probably done this yourselves. You go to YouTube or a site like that that does progressive download of the video, and you go and you start playing some video that looks interesting to you. And as you start playing, maybe you're on a FiOS on a really fast connection, or maybe you're on CorpNet. But basically, you have a really fast connection, and you see the progress bar, the download bar on the player fill up really quickly because as you start playing the video, the entire video downloads within, let's say, like 5 or 10 seconds. You start watching the video, and then after about 5 or 10 seconds, you realize, it's not such an interesting video, and so you decide to give up on it, and you go watch something else. But unfortunately, because you have a fast connection, the entire video has actually downloaded to your machine in the time that in the 5-10 seconds you spend watching the video. Why is that a bad thing? That's a bad thing because the provider that's hosting that video, that's actually providing you the video, is paying for the bandwidth and paying for the hosting. So they're paying for the fact that they delivered you, let's say, 100 megabytes of video, but you only watched 10 megabytes of that video. So that's an issue. And so in order to actually cut costs for the providers, we have a feature called bitrate throttling. And what it does is it automatically detects the encoded bitrate of a media file and then throttles the bandwidth, the actual speed at which the server delivers the file to just that encoded bitrate. So despite the fact that I might have a 100 megabit connection to the internet, if I'm playing back a file that's encoded at 2 megabits, the server will actually serve it to me only at 2 megabits per second. And this is flexible and this is extensible, so I can actually go and configure how I do it. And we support a variety of popular file types such as WMA, WMV, MP4, and so on. And among them, we also support MP4 files as well. So MP4 file support is built into bitrate throttling already. If you want to extend it to other HTML5 file types, such as, for example, WebM, you can do that. There's basically an XML schema that you just have to go define and kind of tell bitrate throttling where to look for bitrate information in the file header itself. And once you define that, it can go and do the same thing for WebM files as well. So I'm going to do a quick demo. In fact, actually, rather than do a demo, actually, I will go ahead and do a demo. I'm going to go ahead and clear my cache just to make sure we're not pulling it directly from the cache. All right, so let me see if we can make this happen. So I'm going to go ahead and play this video from my server. I already have bitrate throttling enabled. All right, excellent. So one thing that you might have noticed is if we zoom in, this is my network activity. And you notice this sort of like peak that happened, where basically it surged at the very beginning. And then you notice that we have a more consistent delivery of media afterwards. If we go back, and if you actually look at my progress bar down here, you notice that, so I don't know if you can see that from up there, it's kind of just a different shade really, but my current seek bar, my current seek position is right here, this is what I'm playing, and this is how much I've downloaded so far. So even though I'm playing back this file from my local server, and really it should just kind of download entirely right away to my browser cache, my server is only actually letting out just slightly more, just slightly, it's giving me just slightly ahead of where I am right now, because it's looking at the encoded bitrate of the file and just giving me just slightly more of that video. So as I'm playing here, this is actually only how much I've downloaded so far from my local server running on this machine, and that's because I have bitrate throttling enabled. So if I stop watching this video right now, I haven't wasted the bandwidth of delivering the entire file. I've only basically delivered this very small chunk of file, this 1 minute or so. And so there's another feature of IIS Media Services that I just want to talk about last, and that's the Transfer Manager, which is currently in beta. We should be releasing it fairly soon, the version 1.0. And it's a very interesting, useful feature if you're running a service that basically transcodes videos, where people submit you videos and you need to transcode those for publishing to the web. Because the Transfer Manager, what it does is actually it allows you to automatically transcode videos on the server unattended. It uses expression encoder on the back end that can be actually extended to use third-party encoders as well, but by default it uses expression encoder. And the way it functions is by monitoring watch folders. So you can go and define a watch folder that says, anytime a video file is dropped into this folder, I want to go use this encoding preset, and then I want to go copy the output to this folder over here. So you can essentially go in there and say and define an MP4 encoding preset, encoding task, and then any file you drop into that folder will get transcoded to an H.264 MP4 file. So rather than doing it manually, this is a very easy way of automating that task. It's fully scalable, so it can be used on HPC clusters. And it supports custom tasks and task chaining. So for example, and this would be outside of the context of HTML5, but if you wanted to do something like transcode the same video to MP4 and smooth streaming, you could do that with chain tasks. You could then also add a DRM protection task on top of that so that the smooth streaming asset gets DRM encrypted as well. And then you could even, for example, take the MP4 file and transmux that to, for example, to an HLS file as well for delivery to iOS devices. So these are all features of the Transfer Manager, and you can essentially do this all as a sort of a chain set of tasks on a single source file. Like I said earlier, only the MP4 task would really apply to the HTML5 scenario here, but that's something that you can do as well. And so finally, just a word about Windows 8. The HTML5 development skills that you've been working on for so long, they will actually be directly applicable to building Windows 8 apps, Windows 8 Metro apps. I won't give you too much information about this because we've actually talked about it a lot at a recent Windows Build conference that was down here in California about 2 months ago. So there's 2 excellent sessions at that conference that are available online. You can watch them, and I recommend that you watch them, to talk about Windows 8 Metro and media and how you essentially build media apps for Windows 8 and how HTML5 fits into that whole thing. So that is the end of my session. Thank you very much for attending, and I'm going to open it up for questions now. And I think it's a pretty small room, so you can just kind of shout it out if you have questions. Go ahead. We have no plans to announce right now about porting Silverlight to iOS or anything like that. But ultimately, it's not even necessarily just up to us because iOS is Apple's product, so they kind of control really what goes into that.
So you don't support that manually, but you support plugin?
Correct, yeah.
And you also said that it won't support video.
Mm-hmm.
So why is the difference there? Are you sort of giving some extensibility on the file format in one place, but your own native technologies?
Right. That's a very good question. I think there's obviously some drawbacks to the plugin approach because it requires an additional download and so on. And so I'm not sure I have a good answer for that right now. So one of the things to actually also consider is that, and that's actually, thank you for asking that because you reminded me of something else that I was going to bring up. So adaptive streaming is a question that gets asked very frequently about HTML5 because it's obviously a big sort of hole in the whole HTML5 video story is that the lack of adaptive streaming. And right now what we have is we kind of have the market fragmented between 3 proprietary technologies. We have Microsoft Smooth Streaming, we have Apple HLS, and we have Adobe HTTP Dynamic Streaming that are essentially the 3 dominant adaptive streaming technologies. And I think there's actually a light at the end of the tunnel because right now we're about a month away probably from a spec being published from MPEG called MPEG-Dash. And MPEG-Dash is MPEG Dynamic Adaptive Streaming over HTTP. And that is an effort actually in the industry to come put together a uniform adaptive streaming spec for the industry. And actually all the companies that I mentioned are actually on board of that, or at least were contributing to that specification. So Microsoft was involved with that, Apple was involved with that. A lot of other companies such as Akamai, Qualcomm, a lot of consumer electronics companies were involved with that. So I'm hoping that rather than go down this path of adding proprietary extensions to browsers for the proprietary adaptive stream technologies, we can all kind of get on board the MPEG-Dash train and really start looking at supporting that in the browsers. And that, a part of that will probably have to go through W3C, obviously, if we want to get it formally into the HTML5 spec. But even if we can get the consensus amongst the companies, we might see just sort of voluntary adoption of MPEG-Dash in browsers as well.